Hi all, welcome to the Unity Complete Shader course. In this course, we learn everything related to shaders, from what is a shader to shader graph, how, to how to write your first shader program using HLSL programming language. I divided this course into several modules and I'm planning for 33 lessons. So each lessons is dedicated for each aspect of the shaders like shader graph, procedural animation, vertex manipulation. And from here, from the module 5, we are starting to do this shader programming. And we are doing complete shader programming to advanced rendering techniques. Each module have its projects, assignments, and everything. The materials for each topic is available through the link in the description. Okay, so without further ado, we can start from our first topic, that is, what is a shader? Shader is a small program that runs directly on the GPU. Its the main job is to how to draw an object on the screen. It takes in a 3D model data like position, corners, textures, everything, and output the final colored pixel which we seen on the screen. Consider this a 3D scene. In this 3D scene, there are several 3D objects like the trees, flowers, and several objects are there. These are all in 3D. So the idea of any graphics programming is to convert this 3D model, which includes the textures, the position of various objects, and the movement of like the swaying of grass and movement of leaves, every data, and convert it to a 2D image which we can project onto the screen. So we have a 3D data which we transform into 2D image, or we can say that the pixels on the screen. So there is a transformation happens from the 3D to 2D. This happens mainly on CPU and GPU. In this transformation, very complex type of transformation like the changing the vertex, changing the color, like that complex type of transformation is handled by the GPU. So CPU will prepare and send data to the GPU, and GPU do the processing. One of the important aspects of the GPU is the parallel processing. And once the processing is done, it will send back to the CPU to show this image. So that is the rendering is happens. So this is one of the loosely description of the render pipeline. So the render pipeline have two stages, a vertex stage and a fragment stage. So by the name vertex, we can say that it's all about the position of each vertex of an object. For example, if this is a 3D cube and these are the vertex. So each vertex has position. For example, this is at an origin, this vertex is at an origin, and every vertex have its own position. So we can manipulate this position, or we can increase the size. We can transform the cube rotate, everything. So everything that type of transformation happens in this vertex stage. This fragment stage is basically all about the color. So we color each segment or each fragment uh, of this object. So we have this input data. The input data is coming to this vertex stage. That is our first stage. After the vertex stage, we pass the data into the fragment. This is the second stage. And from here, we get the out. Okay, so here comes the importance of the shaders. The shader program manipulate or control these two stages of the render pipeline. Based on the intention and the purpose, the shaders can be classified into many types, like vertex shaders, fragment shaders, geometry shaders, compute shaders, like that. So the vertex shaders manipulate the position and size and everything of the vertices, and the fragment shaders changes the color and other effects. So a shader, we can say is that a program which affects or manipulate these two stages of the render pipeline. So this description of render pipeline and shaders are a very simplified, loosely described. Okay, actually the render pipeline is very complex thing, and the shaders and the shader programming is also a complicated thing. We just simplified it for to understand easily. So as we mentioned before, the CPU prepared and sent the data to the GPU. So shader, our shader program accept this data, a- accept this data, and we also give some sort of a logic in the shader program, and this output some data. Okay. So the input data have maybe many things, like maybe it have texture, it have integer value, float value, color. Several things will be have in the input side as the data, and the output have some data. We also give apply some logic upon this input data. Okay. So in the case of a Unity, this output data is, we cannot directly give this output data to an object. We cannot directly do that. So what we have to do is we give this data in order to create a material. And then this material is attached to the object. So this is the workflow in the Unity. Even though the idea behind the shader is universal, but how the shaders are applied to each object is different for different platform. For example, Godot, Unreal, Blender, etc. So this is in nutshell, this is the basic idea of the shaders, the shader program, how the shaders has affect the render pipeline, how a 3D scene or a 3D object is delivered to the two-dimensional image, like that. In the next video, we will dive deeper into this render pipeline, especially the render pipelines for the Unity, for example, the URP and the HDRP. I will see you in there.